Welcome back to Africa Science Focus, the science and development show from SciDevNet and Ogechi Kenyan. In this episode, we learn about Africa's space sector and how some of Africa's space scientists are starting to find answers to the continent's developmental challenges by looking beyond the ground and turning to space. Technologies like satellite imaging, communication systems, and GPS are no longer just tools for the world's largest economies. Across Africa, they're being used in powerful ways like helping farmers detect crop diseases earlier, improve disaster response, tracking climate patterns, and connecting remote communities to the internet. The work is already starting to make a real difference, but the journey is still at an early stage. Most of Africa's national space agencies have been established within just the past 2 decades. But despite the sector's youth, progress is picking up. In 2024, Africa's space economy was valued at $22.64 billion, and it is expected to grow strongly over the next few years. So in what ways is Africa currently utilizing space science? What innovations are emerging? And what challenges still lie ahead? Our reporter Michael Kaloki spoke to scientists and innovators across the continent who are using space-based research and technology to tackle real-world problems and build a stronger future for Africa in the process. The scientists also tell us why investment in Africa's space sector is important now more than ever. First, we speak to Daniel Okoh.
So I'm sitting in a classroom at the Technical University of Kenya. And with me is Dr. Daniel Okoh. He is a research scientist at the Space Environment Research Laboratory at Nigeria's National Space Research and Development Agency. Dr. Okoh is here at the Technical University of Kenya working on the DARA project. Now, the DARA project stands for the Development in Africa with Radio Astronomy project, which is taking place here at the Technical University of Kenya. And as I look around me here, I see a blackboard with several algorithms, which, look very complex to me. But anyway, before I discuss that further, maybe I should get you, Daniel, to introduce yourself, please.
Okay, thank you so much, Michael. My name is Daniel Okoh. I'm a researcher with the Space Environment Research Laboratory of Nigeria's National Space Research and Development Agency. So I presently work on some projects that apply AI and machine learning to develop models of the ionosphere over Africa and to a larger extent the globe.
Now, you're presently working on this DARA project. Could you tell me a bit about it?
Okay, so the DARA project is a project that is being operated by a team that is centered at the Leeds University in the UK. And the essence of the program is to support and advance research, especially in the areas of space science and astronomy on the African continent. So this project somehow has supported a lot about the SKA, which is the Square Kilometer Array that is being hosted mainly in South Africa and then in some other African countries, of which Kenya is part. There's also Ghana and a number of African countries in this collaboration. So yes, the DARA project, it's been for some years on now, and it has immensely supported research and development in the areas of space science and astronomy.
Now, as I look around me in the classroom, Dr. Okoh, I see a board here, a whiteboard, which has several algorithms in it, equations on it. It looks very complex. Is this about science?
Yes, it's actually a lecture. I took some master's level students on the area of space plasma and space weather. So it's mainly an algorithm particularly showing the way electrons and ions, charged particles, would move in electromagnetic fields. So that is what you're looking at.
Thank you, Dr. Okoh. Now, what significance would you say space-driven research and innovation hold for the African continent?
Okay, there are very large. In fact, when I think of space research in Africa, there are endless possibilities of the things I see that can be done and need to be done. So first of all, looking at our communications, our telecommunication systems that are fast evolving, even the navigation systems. Africa, no doubt, is far behind when you compare to other parts of the globe. So it calls for a lot of interest, and given the position of Africa on the continent. So Africa is located equatorially. It's one of the continents that has a huge mass of the land mass within the equatorial region, and this is where a lot of activities happen in space that interfere with communication and satellite navigation systems. So for what we do and for the research that we put forward, I see that there are lots that we still need to do. And it's not to say that much over, if we look back in the years compared to the last 5 years, we would say that a lot has improved in space research in Africa. And this is thanks to a lot of international organizations, a lot of African organizations. The space agencies within Africa have also done a lot to see that Africa research is pushed forward and that we get some values. But yes, there are still so much to be done. For instance, there is no single African country that is thinking right now of a satellite-based navigation system. And this is not to say that what we have globally is not sufficient. We have the GPS from the US, we have GLONASS from Russia, the Chinese have developed Beidou, and the Japanese are developing their system. The European Union also have their Galileo. And so if we look at all this happening, we'd see almost nothing happening in Africa in this regard. So there's a lot we need to think about and come up with indigenous technology for we that are Africans.
How, Dr. Okoh, would the African continent come up with these indigenous technologies? I mean, could you give me an example of an indigenous technology, or what could you term perhaps as an indigenous technology?
Okay, so indigenous technology in the sense of technology that is local to Africans. So it's driven by Africans, and Africans know the way to maneuver or change what needs to be changed. So the bulk of the technology is local, and there are quite a lot that comes into especially space science. For example, in the area we work on modeling, we see a scenario where international-based models underrepresent Africa. And this is obviously due to the reason that we have very sparse or no data from the African continent. So, for example, if we talk about the International Reference Ionosphere, it's a model of the global ionosphere. And the ionosphere, to make sense of how valuable or how important it is, the ionosphere is part of our atmosphere that affects radio signals. So they interfere with radio signals, especially communications between satellites and Earth. So most of our technologies are based on these communications between satellites in space and Earth. So the ionosphere is plays a very huge part or influence in these communications. So when we look at this global model of the ionosphere, what we've realized over the years is that in most cases of Africa, the model does not perform as well as it performs in continents like Europe and the US or the Western communities, especially because most of the data or results, information that are used to develop these models are based on ones collected in these places, and very little or none at all come from Africa. So when we talk of African indigenous technology, we want something that takes a lot of consideration about Africa. And in particular, one of the projects we've done is the AfriTech it's our African Regional Ionospheric Total Electron Content model. So it's also a model of the ionosphere, but developed strictly on data that is collected from the African region and trained, also developed using very current methods of AI and machine learning. So over the years, also, this model has been tested and shown a lot more times to be better than the international existing models.
Michael spoke with Mary Makuate, a researcher at Cameroon's Ministry of Scientific Research and Innovation, and she shared insights from the 2024 New Space African Conference.
Mary, if I could kindly ask you to introduce yourself, please, too.
Thank you so much, Mike. Hello, my name is Mary Makuate. I'm a Cameroonian researcher for the Ministry of Scientific Research and Innovation, and I'm also the founder of Geospatial Girls and Kids.
Thank you, Marie. Now, Marie, you have a keen interest in outer space and satellite technology. How did this interest develop?
Yeah, my interest in space and satellite technology has developed over many years, stemming from my childhood curiosity about the world beyond what we can physically see. So growing up, I was always fascinated by the idea that there's so much more happening outside our continent, our planet, that influence our everyday lives. So it was during my academic journey, particularly my master's degree, when I started studying geospatial science and technology at the Afijis in Nigeria, that I realized how powerful space and satellite data could be solving real problems. So I've been passionate about finding innovative ways to address societal challenges, and space technology holds many promise in this regard.
Thank you, Marie. Now, at the 2024 New Space Africa Conference, you moderated a discussion that looked at how innovative solutions are helping address pressing issues on the African continent. Could you tell me about some of the highlights of this discussion in relation to how space-driven innovation and research can help the continent address its pressing issues?
Last year at the New Space Africa Conference that happened in Angola, I moderated a session, and during the session, we focused on the transformative potential of space-driving innovation in addressing Africa's development challenges. So one of the key highlights was the role of satellite data in enhancing agricultural practices. You know, agriculture is one of Africa's most vital sectors, if I can say it like this. Yet it faces several challenges, such as unpredictable weather pattern. Here in Cameroon, actually, we are supposed to be in a rainy season, but we still have sun. We are still expecting rain. So poor soil condition and low yield. So satellite data can help farmers monitor weather condition in real time, track the health of crops, and predict the best time, especially the best time for planting and harvesting. By leveraging this technology, farmers are able to make more effort, more information. It can reduce risk and ultimately improve food security across the continent. Another area we explore was how space technology plays a significant role in disaster management. Satellite can provide real-time monitoring of natural disasters such as floods, earthquake, enabling government and many humanitarian organizations to respond more effectively. For example, during a flood, satellite images can identify the affected areas and provide critical data for evacuation plans and resource distribution. This capability is crucial for minimizing the damage caused by natural disaster, and why not saving lives?
Now, you create maps through the use of satellite data to assist communities on the continent who are dealing with emergencies. Could you tell me more about this and the impact the maps you create have had in regards to assisting these communities?
Oh, yeah, that's a good one. Creating map using satellite data has been one of the most rewarding aspects of my work. Yeah. Satellite technology provides us with the ability to monitor and respond to emergency in real time, providing crucial data that help save life and reduce damage. During emergencies such as natural disaster, including flood, hurricanes, or disaster outbreak, having accurate and up-to-date map is vital for an effective response. Satellite imagery allows us to identify affected area, track the extent of the disaster, and plan evacuation routes and resources distribution. One significant example of this work was in 2023 during the earthquake in Morocco, where I worked with the humanitarian OpenStreetMap team to create detailed maps that were shared with humanitarian organizations all over the world and the Morocco government. Our map were used to assess the damage, identify areas that require immediate assistance, and guide rescue operation. So the real-time satellite imagery help responders coordinate their effort more effectively, allowing for faster access to affected community and ensuring resources were directed where they were needed most. So yeah, during this collaboration was critical in saving life and minimizing the impact for disaster.
Now, you work at Cameroon's Ministry of Scientific Research and Innovation. Could you tell me more about your key research at the ministry and the impact it has generated?
Oh, sure, yeah. I currently work at the Ministry of Scientific Research and Innovation, where my research focuses on a variety of areas critical to Cameroon development and the broader Central African region. One of my primary areas of focus is using satellite data and remote sensing technology to promote forest restoration. Because if you know the Congo Basin forest, degradation is so high, actually. So I'm trying to promote forest restoration within the Congo Basin, one of the world's most vital ecosystems. The Congo Basin is crucial not only for global biodiversity, but also for the fight against climate change. Through remote sensing, I'm able to track deforestation, monitor forest health, and access restoration efforts. This research plays a significant role in ensuring that the Congo Basin is managed sustainably, which has far-reaching impact on both environmental conservation and local communities that depend on these forests for their livelihood.
Thank you, Marie. Now, from your perspective, is there sufficient space-driven research being undertaken on the continent? And what can the continent learn from other parts of the world regarding space-driven innovation and research?
Oh, yeah. While there has been significant progress in space-driving research across Africa, there's still much work to be done. Yeah. Many African countries are establishing space agency and satellite program. Many African countries are launching their own satellite that very appreciate. But the research infrastructure remains underdeveloped in comparison to other regions of the world. Yeah. In order to fully harness the potential of space technology, we need more investment in research, capacity building, and the creation of supportive ecosystem for innovation. African can learn a lot from countries like, India, China, why not even the United States, where space research is integrated into national development strategy. Yeah, here in Cameroon, we don't have a space national development strategy, which is not normal. So African countries can, how can I say, they can focus on those countries. And those countries have shown that space-driven innovation can contribute to solving key challenges like climate change, food security, and so on and so forth. One key takeaway for Africa is the importance of long-term investment in space education and research. I insist on space education and research, building strong research institutions, fostering collaboration with International Space Agency, NASA, ESA, JAXA, and so on, and providing resources for young innovators will be crucial for Africa to leverage space technology for development.
To help inspire the next generation of African space scientists, we also spoke with Susan Murabana, co-founder and CEO of the Travelling Telescope Africa Ltd. Susan shared how she's working to make space science more accessible to young people in Kenya.
I wish I had that story of looking up as a young child and wondering about the skies. I grew up in Nairobi, and I can't tell you what the night sky looked like growing up. But what inspired me into space is when I was about 20, I joined a group of explorers, and there were scientists who were traveling across Africa after a solar eclipse that come from Zambia and are coming to Kenya. And I joined them, and they were teaching basic science in schools. This group had a telescope. They were mainly grad students from the US and UK and a few Africans. And I happened to look through the telescope in a really remote part of Kenya, and I saw Saturn and its rings, and it was floating up in space. I saw the moon and the craters on it, and I saw planets, and I saw a lot of stars with my naked eye too. But I think for me, looking through the telescope and seeing Saturn, that planet floating in space, and seeing the rings was powerful because it was no longer a textbook image. It was the real thing. And I was taken back to my own planet and reminded that we are floating in space, and we're traveling, and it was just a life-changing moment. But at that time, I really wanted to share my experience with school kids because I had never experienced that as a schoolgirl. And I felt if I did, I would have had a very different approach to science and learning.
Thank you, Suzanne. Could you tell me more about could you tell me about the Hands-on Universe program and your participation in introducing a research-based astronomy education curriculum into Kenya's secondary schools?
The idea of Hands-on Universe was to train teachers on astrophysics tools and concepts. I had very little knowledge about astronomy, very minimal. And I knew that in Kenya, I had never looked through, I'd hardly looked through a telescope. I'd only looked through a telescope once or twice through Cosmos. And I knew many people had not looked through telescopes and everything. And yet the program was encouraging students to manipulate data from telescopes that were automated, which was, proper research through their teachers. So you train the teachers and the teachers would work with the students. But they were flexible. I preferred the approach of working directly with students. They were also adaptable. I was able to, bring in the concepts of let's get a telescope. Let's try and get kids to look through a telescope. In fact, my very first telescope was a donation by a local Kenyan company, Pulse Healthcare. And I would take it around mostly Nairobi at that time, and kids would look through. And there's something about the sky that fascinates everyone, but really young people are so genuine. They're not scared to express how they feel. So we did that, but also I worked with two high schools, Kenya High School and Nairobi School, bringing this program where the students would access data and manipulate data, do astrometry, do a bit of photometry, try to measure the craters, the size of the craters of the moon and things like that. So it was really a fun experience for them. In terms of learning, we had at some point about 60 students from the girls' Kenya High School, and maybe 60. There's a time we did a combined session. Sometimes we do, at the time, use Skype to do a virtual session. We also at some point had a physics Nobel Prize winner, George Smoot, who joined in and talked to the students and the teachers. So it was a really interesting time. I did travel to their regular annual meetings to present what I was doing in Kenya, and eventually I was invited to the US to UC Berkeley as a short-term scholar in 2011 for about 7 months to learn more about, the proper work they do in UC Berkeley.
Thank you, Susan. Now, why do you feel it is important for students to be introduced to space research?
I think there's a lot. So right now I run company. I co-run the company called the Travelling Telescope. And what we do is two main areas of focus. One is astrotourism, where we provide astronomy experiences, what we call a star safari. We give you a guided tour of the night sky. And views through the telescope as an extra service to your guests. So Kenya is beautiful. It has beautifully dark and polluted skies, mostly in parks and rural areas, and it's right at the equator. So what does that mean? It means that for visual observing, when objects are right up there, they're very good to look at. There's less atmospheric interference. So if you're looking at Saturn or Jupiter and they're right up there, they look really crisp, clear. And so it's really nice to have that. And we've done that with quite a number of lodges and had quite a number of guests look through. We have a monthly stargazing night. But in addition to that, I think education is a big thing for us. As I say, the first time I looked through a telescope, I thought of my school days. And so we go to schools. We try and go to all schools. It's difficult at the moment to access the schools we want to, especially the public schools, because it's a time, it's funding and things like that, because we do not charge the public schools or the underserved schools. So those are the two things we do. Now, we go to schools that are in the city. Some are international, which we charge a minimal fee, but we also go to very remote schools. And I think what really gives us a lot of comfort when we go to some of these schools is, especially in remote areas, they have this beautiful sky, which is like a whole laboratory for them. And for us with the telescope, we're just introducing them to the sky, like revealing something they already have, and hopefully leave them with a more interesting, questioning and figuring out, or trying to figure out what's out there. But most important for us is giving them the opportunity, or making them know that there's a huge space industry waiting for them. And it doesn't have to be only in astronomy. It could be in engineering. They could build rockets. It could be in law. There could be space lawyers. It could be in communication. There could be science communicators and, break down what's happening in space. So we hope that we are opening for them opportunities that they would not have otherwise thought of, but also just trying to give them that idea that they can be more than where they come from, that community, that county, that country. They can be part of a global community through space. So I think that's one important thing for us is, of course, it would be wonderful if all the kids you go and see want to be astronomers or scientists. But it's good if really they look up and they see they can access much more than they have.
That's all from us at Africa Science Focus today. If you want to find out more, head to the SciDevNet website. That's www.scidev.net. Today's show was produced by Alice Hurst, with editing by Titilope Fadare and Ogechie Kianyawo, and reporting by Michael Kaloki. I'm Ogechie Kianyawo. Until next time, it's goodbye. Africa Science Focus is produced by SciDevNet and distributed in association with your local radio station. This podcast was supported by the Science Granting Council's initiative, which aims to strengthen the institutional capacities of 18 public science funding agencies in sub-Saharan Africa.